Measurement sciences. The way we measure life. Rulers, measuring cups, gallon containers, jugs, buckets, barrels, bins, warehouses, fuel bunkers. We measure the volumes of those things. Square inches, gallons, cubic meters, number of different measurements. These measurements have developed since before we began writing. When we began writing about them, we began refining them, sharing them, so more people could do these types of measurements. This is the generic measurements word. Anything you can think of that you use for measurement. Weight, how much do you weigh? How much do you weigh your cooking ingredients versus measuring by volume? Some people do, some don't. Both ways work though. And you can do it in metric or you can do it in SAE, pounds and ounces, or liters and milliliters, or grams, or land in hectares. So these measurements, understanding these measurements and the terms for them. If you go to another country and see speed limit signs in kilometers, how do you handle that? Personally, I look down at the speedometer. Most of them have both miles things on there, so I can quickly convert from one to the other. Or if I get lucky, a car has a button that will show you one versus the other. Or you get used to reading kilometers and following those kilometer speed limit signs, because that's probably why you're paying attention. So measurement sciences, what do we measure? Well, let's see. We've sent a probe circling the sun. It's been doing this for a little while now, gathering data and sending it back to Earth. Unimaginable data. Well, it is imaginable because you can go learn about it, understand it, and find out about it. So that's one of the things we've done in measurement sciences. So where does this come back? It comes back to measuring lead in drinking water. Another city in Michigan has been mentioned as having problems. And the problems being measured for years and not being responded to. So someone was taking measurements, valid measurements according to the rules, and someone else was not understanding what those measurements mean. Lead in drinking water makes people ignorant, dumb, mentally impaired by a known product of man's own, nature made it, we're just abusing it. Nature didn't spread it across the planet like we have. So these measurements, understanding these measurements is kind of important, and it's also overwhelming. The root of understanding measurements right now for America is being maintained by NIST, National Institute of Standards and Technologies. And you will get lost even looking up the basis of your ruler and how it's a standard, and why your ruler might not be as good as somebody else's ruler. The no true ruler fallacy. So these measurements, there's a website I've referred to before, earth.nullschool.net, is displaying measurements from satellite information. That satellite information is verified against ground station information. It's supplied by a number of countries' satellites and ground stations, put together into a data stream, earth.nullstream.net. It really is an amazing piece of presentation material, presentation overlay to existing data that we have. So these measurements, they're important to understand. Also the challenges because there's so many measurements and relating one to the other. I mentioned miles versus kilometers. The other common one is centigrade versus Fahrenheit. I use Fahrenheit. I'm used to it, and it has a better granularity than centigrade or the Celsius scale. So measurements can get overwhelming to think about. But understanding that there are people that do know them and work with them, how they work, is part of the clues to life and existence today. We measure things so finitely. I've watched the technical progress of the measurement sciences because I was trained long ago in them. But they've changed. They've gotten better. They have only gotten better. So, understanding measurements. I mentioned drinking water. Part of this is trying to figure out who and how measures drinking water quality effectively. It appears states have different rules. The labs that will provide you with information have different rules. And then there is very precise testing, like elemental analysis, that is outside of those rules. It's barely mentioned. It's a common lab procedure inside very technical labs. Elemental analysis, identifying to the isotope level, like lead, because there are a few forms of lead. Lead identifies where it came from. Lead is the result of nuclear decay of fissile materials. Lead is the result of a release from a volcano. Or lead is the result of a release from fuels, coals. We just recently are trying to get rid of lead in aviation fuel. Long overdue. And yet it's barely a conversation out here. And it's going to affect the aviation industry. Measurements, understanding what they mean. I'm interested in radioisotopes and their travels. I also follow lead and its travels. It's difficult to understand these labs unless you've been in and out of them, I suppose. These labs are very specific. Some of them were dealing with mostly ceramic materials in the aircraft industry. Some of them were dealing with ship steel and failure modes for shipping-related accidents and incidents. Metallurgy labs, ceramics labs. Another was an environmental lab studying the biological uptake of basically oil field residues in inland marshes in Louisiana. Another lab was testing the groundwater supplies to map the aquifers for this nation, testing water to levels not required anywhere outside of research and science labs. Good luck. Peace is out.